For number 4, we have that the maximum highway speed limit in British Columbia is 110 kilometers per hour. So again, what we do is we say this is what's given, 110 kilometers per hour. And in this case, we want to express this speed, so we're not doing a calculation, we're just doing a conversion. And the new unit we want is meters per second. So I like to put meters per second over to the right. That's the unit we're trying to get to. So we need to get kilometers to meters, and we need to get hours to seconds. So remember, kilo means 10 to the 3, so 1 kilometer equals 10 to the 3 meters. And we can also use that 1 hour equals 60 minutes, and 1 minute equals 60 seconds. I'm going to put these conversions in so that kilometers cancels. So the first one, we're going to put in 1 kilometer on the bottom, and that equals 10 to the 3 meters. That'll be in the numerator. Kilometers cancel, so great. I have this unit. I'm in meters. The next one we're going to put in is we need hours to go away, so we're going to put 1 hour on the top of the fraction, the numerator, and that equals 60 minutes. So now hours is canceled, and we are now in meters per minute. And that's not what we want. We want meters per second. So we put 1 minute is equal to 60 seconds. Minutes cancels, and we now have the correct units. We have meters on the top and seconds on the bottom. Everything else is canceled. So when we do this calculation, you should get an answer of 30.6. But since there's 2 sig figs here, we need to round that to 2 sig figs, 31 meters per second. Number 6, we have the energy consumption of a Samsung refrigerator is 5.47 times 10 to the 2 kilowatt hours per year. Don't worry if you don't know what the unit is. It's going to give you some conversions. It says what is the average energy consumption, so we haven't changed what we're reporting. We're just converting. Average energy consumption is this. What is it in this new unit? Gigajoules per day. So we're going to put gigajoules, and you know that's the unit because in the context of the problem you have it right there, per day. So it's a conversion, and we're told, another piece of information we're given, 1 gigajoule is equal to 277.8 kilowatt hours. Well, that's good because we're going from kilowatt hours to gigajoules, so that's an easy one. And we're also told that 1 year is equal to 365 days, which I think you knew. So now if we do this conversion, we'll put in that 1 gigajoule is equal to 277.8 kilowatt hours. So we'll put kilowatt hours on the bottom, 1 gigajoule on the top. And then we want years to go away, so that's going to go on the top. 1 year is equal to 365 days. Years on the top cancels years on the bottom, numerator, denominator. Kilowatt hours in the denominator cancels kilowatt hours in the numerator, and we are left with the correct unit that we wanted, gigajoules per day. When you do that math out, you should get 0.0054. I'm sorry, you should get 0.00539 if we're going to keep the right number of sig figs, because there are 3 sig figs in this kilowatt hours, and there are 4 in that conversion and 3 in this conversion. So if I want to rewrite this in scientific notation, I would say 5.39 times 10 to the minus 2 gigajoules per day. Number 8 gives you a density of 13.6 grams per milliliter. It asks you to find the mass, so that's the unknown, if the volume, which is also given, is 1.00 liters. So that's the information, givens and unknowns. It also specifies that you want the mass in kilograms. So this is not a conversion. We're given density and volume. We want to find mass, so this is a calculation. We know that density is equal to mass over volume. If we want to find mass, we multiply both sides by volume, and we get that the mass is equal to the density times the volume. So here's the equation we're going to plug into. Now, if we look at our units, let's just identify our units. The density is in grams per milliliter. The volume is in liters. I need them in the same unit. If I'm going to multiply in this formula, I need all of the units to cancel out and work. So I want to put grams per milliliter here. I can't put liters here. That won't work. That won't cancel the milliliters. So I'm going to convert my volume to liters first. I'm going to say that I know that, let me just erase this little arrow here. I know that milli means 10 to the minus 3, and I want to convert to milliliters. So I want to get rid of liters. 1 milliliter is 10 to the minus 3 liters. And so we're going to end up with 1,000 milliliters, which 1 liter is equal to 1,000 milliliters. It's okay if you want to use that conversion that you've learned before. So we're going to take, that's our volume, and we're now going to use our equation that the mass is equal to the density times the volume, which equals 13.6 grams. Oops, that's a 3. 13.6 grams per milliliter, that's the density, times the volume, 1,000 milliliters. And so we get that the mass is equal to 13,600 grams. Milliliters has canceled, and we get 13,600 grams. But the question said in kilograms. So this is correct. But in kilograms, we'll do this conversion at the top here. 13,600 grams. Now we know there's 1,000 grams in a kilogram, but just to be consistent with our conversions, we're going to say kilogram is what we want. Kilo equals 10 to the 3. And so if we do that math, it's like dividing by 1,000, and we get 13.6. And so 13,600 grams is the same. Canceling out our grams, we get kilograms. So I'll just answer down the bottom. This is the same as 13.6 kilograms. Number 10. You're given the density is equal to 10.5 grams per centimeter cubed. You're given the mass of the object is equal to 6.00 grams. You're asked to find the volume, and you're asked to find it in milliliters. This is another calculation problem. It's not a conversion. We're looking for volume. So we know that the equation that we can use is density is equal to mass divided by volume. And if we're trying to find volume, we'll isolate the V by multiplying both sides by V. So we have volume times density is equal to mass, and then divide by density. And we get our final equation we're going to use is that the volume is equal to the mass over the density. Now, mass is in grams, and density is in grams per centimeter cubed in this problem. So if we plug that in, the grams will cancel, and that will be fine. We don't need a conversion at the beginning. So 6.00 grams divided by 10.5 grams per centimeter cubed. And remember, we said that this unit on the bottom, because it's on the bottom, it ends up flipping. So this is the same as putting the centimeter cubed up to the top. That works the same way. Okay, so the grams cancel, grams over grams, and we end up with 0.57, and I need another sig fig. So 0.571 centimeters cubed. And since 1 milliliter equals 1 centimeter cubed, we can say that our final answer is that the volume is 0.571 milliliters. Number 12, I'll leave you to do. It's very similar to the cat problem. You should end up with 630 of the sheepdogs. The German sheepdogs, I think they were. That should be the answer. Number 14, you're given 325 cubic inches, and you're asked to find what is that equal to in liters. So this is a conversion. We want to know, convert this to liters. This is a volume. A cubic inch is just, if you measured 1 inch by 1 inch by 1 inch, that would be a cubic inch of every inch. So we know from some other problems that we've already done now that 1 inch is equal to 2.54 centimeters. These are the conversions I would use. We know that 1 centimeter cubed is equal to 1 milliliter, and 1 milliliter is equal to 10 to the minus 3 liters. And so the equation that I have written out here starts off with what you know, 325 inch times inch times inch, because we know that we had cubic inches. And we're going to convert the 3 inches with our 3 centimeter to inch conversions shown here. 1, 2, 3. And then we're going to convert that 1 milliliter is equal to 1 centimeter cubed. That's this one here. So we're going to use that here. And then we want to go from milliliters to liters. So we're going to convert 10 to the minus 3 liters is 1 milliliter. And when you do all of those calculations, you should end up with 5.33 liters. Number 16 is worded a little bit funny. The wording on this says that you can, if a gallon of paint, 1 gallon of paint, covers 400 square feet, then the question is, what is the paint coverage expressed in square meters per liter? So we want to know this same coverage expressed in square meters per liter. So what that means is this is telling you that if you had a gallon of paint, you know, take your paint, and you were to paint it, you would paint an area that's 400 square feet. So we can write this as 400 feet squared per 1 gallon. And we want to get to meters squared per liter. This is a straight conversion. It says express this quantity in these new units. That's what the question asks. And it also says, well, 1 gallon is equal to 4.546 liters, which we know now from many of the other problems. So we also know that we have to get from feet to meters. So I just looked it up online. I don't think it was given in this worksheet, and we can say that 1 foot is equal to 0.304 meters, or you could have defined it as 1 meter is equal to 3 point some, I forget the exact number. Let's see. 1 meter is equal to 3.289 feet. So I'm going to use this conversion, and we're going to go from feet squared to meters squared. So we say 0.304 meters for 1 foot. And we have to do that twice because it's 2 feet, it's a square feet. 0.304, that's a 0, meters is equal to 1 foot. So feet cancels feet squared. There we go. And then we want to go from gallons to liters. So we'll put our conversion 1 gallon is equal to 4.546 liters. And the gallons will cancel gallons, and you'll end up with your meters squared per liter unit. When you multiply across, you get 8.13 meters squared. So if you had a gallon of paint, you could paint 400 square feet for every 1 gallon. But that's exactly the same as saying that you could paint 8.13 square meters for every 1 liter. Okay, in 18 and 20, I think you can do these with little review, but 18 says 1.9 Kelvin, and we want to get that into Fahrenheit. So you always go Kelvin to Celsius first. So 1.9 Kelvin, and we have to subtract 273 to get Celsius, so we have negative 271.1 degrees Celsius. And then we're going to times it by 9 over 5 and add 32. And if you do that, you're going to get negative 456 degrees Fahrenheit. And likewise 20, if it's 9 degrees Celsius, converting to Fahrenheit, you should get 48.2 degrees Fahrenheit. Okay, and just remember there's an upcoming quiz on conversions and sig figs, and we can be ready for that this coming week.